The second law of motion of Newton, dealing with conservation of momentum along with the law of conservation of energy, remains a key tool for analyzing any type of motion of a physical body. A very popular toy called the Newton's Cradle very succinctly and very elegantly demonstrates this law. This toy consists of a series of spherical steel balls which are hung with two strings to make them swing in a single plane. The balls are hung in a manner that they just touch each other. And to observe the phenomena, the behavior of the ball, if you pull out just one ball and leave it, you find exactly one ball goes out. And we can do it in different combinations. If you pull one ball, only one ball goes outside on the other end. If instead of one ball, you pull two spheres and release it, you find exactly two spheres go on the other side. Surprisingly, if you take three balls and release it, you find exactly three balls going to the other side. One ball from the incoming ball joins the outgoing ball. The entire phenomena can be understood based on the principle that if a moving object of mass m strikes elastically another object of the same mass, the first object transfers all its energy to the second mass and itself becomes stationary. This is brought out in this chart where the equation of motion of second law and conservation of energy is spelled out. To understand the various complex movement of the Newton's cradle, we have to break and reduce it into simple phenomena of single collision between two spherical balls of equal mass. The same phenomena can also be seen in what is called the Newton's Carrom, which will be demonstrated now. This is what we have termed as Newton's Carrom. It's an ordinary carom board where we have laid two heavy books to form a channel in which the coins can be laid. We have got 5 coins laid in the channel. Now we will pull back one coin and strike it on remaining 4 like the Newton's cradle. What we see is a very astonishing phenomena. When we strike with one coin, only one coin goes out. Now we will see it closely in combination of movement of several coins. Now we do with 3 coins. Pull back 3 coins, line them up, see that they are in one line and fire. You find that exactly 3 coins go out. Now we pull back 2 coins, keep them in a line and shoot. We find that exactly 2 coins black go out. In Newton's Carrom, we can have large number of combination of coins and even have 2 players striking from both sides simultaneously. We should also keep in mind that these coins are made of wood and not as elastic as a spherical steel ball. Yet, the Newton's second law holds so tightly that even then we can see it behaving according to the law. Thank you.